All right, welcome back, everybody. May not take too long on this. I need to do, we're doing that. We got CSCI 2. The new command, the delete command, and Destructors. And we've talked about new and delete some a little bit before. What's today? Oh, it's September 11th. Day of mourning. All right, and what do we always need to include? We need to include some IO stream action. I'm going to include, let's include C standard library. That's good practice. Using namespace std. We're going to make int main void. Turn 0. Let's add a little bit of C out in there. Make sure everything's working. All right. Program ran empty. All right. So what are we doing today? We're looking at today's lesson is on dynamic memory allocation. Maybe I should put that up above. Dynamic memory allocation. That's the entire point of this topic. So when we do something like int x equals 5, what we're doing, this happens at compile time. Compile time, memory is allocated, and it's stuck for the life of the program. Now, this kind of sucks. If this was like this is an integer, so it doesn't take up a lot of memory. But let's say this is a video game, and it's not a simple integer. It's a monster. Big bad monster. And we kill it. We're stuck with it. Hogging up memory. Now, how many games you go through with shooter games, you got to go kill a bunch of bad guys. If we hold up that memory for every single bad guy we kill, it just gets a little bit overwhelming. So this is not a good use of memory. So what we do about that is we would rather have something stuff, and it's there for the life of the program. If we do it beforehand, we have to have all the monsters generated ahead of time. We'd rather have stuff generated as it's needed. And deleted once it's not. Think the dead body of the monster. So for that, we have our new command. And to use the new command, we use pointers. So we have an int pointer. Let's call it y, and then we'll call it new int 10. And we can see out y. And let's see what happens when we see out y. We get the memory address because it's a pointer to the address. So don't forget, pointers are pointers to the address, not the item. Not the object in memory. So how do we get around that? We dereference it. And we get the value. And if we wanted to see that as maybe an integer rather than the hexadecimal address, we can get an address like that. So this is kind of like what's going on in memory. Your memory, you got a whole bunch of memory shit, and it's chopped up. It's nice, organized, blah blah blah. I didn't make those very even. That's what I get for being sloppy. Let's say a lot of these are already occupied though. All this block is occupied. We got those are all occupied. Those are occupied. This memory is being filled up with stuff already. Oh, any box that's too narrow for me to write in very well, I'm going to say memory is allocated there. We got a memory allocated like such. And what we did is we came and said, oh, look, we wanted to make an integer x equals 5. We put it into memory, and it goes in the first available one. Let's see if I can. That doesn't help. Can I move this over to the other side? There we go. There we go. Much better. Then we made a pointer. The pointer, so y is storing that address. Let's say y is stored right here. And that's an address. And the address is actually directing me over here. And that's where my 10 is stored. My address is pointing over there. Which is kind of nice. So when we don't need the 10 anymore, we can get rid of it. How do we get rid of it? Well, for every new, there is a delete. For every new, we should have a delete. So I can delete y. So what this does is this deallocates the memory. It doesn't get rid of it. It doesn't get rid of the pointer. And it doesn't get rid of the 10. All it does is says that memory is now free to be used for other stuff. That's all it does. What happens if I try to see out y now? After deleting it. If I try to dereference it. We were still able to show the address where it's pointing at, but that memory is now free to be used. And so we got the memory break, or the memory issue, read access violation on 31. So that's where it collapsed. Pictorially, what we've done, the pointer's still there. The 10 is still there. All it's done is said, okay, if you, ooh, I don't want to use that one. Dry erase, there we go. If you need that 10 for other shit, this memory is free. You can write right over it. And since we can write right over it, it's going to say, even though you've got a pointer here, you can't use that pointer. It's going to tell us no. And it did.
I noticed that that when you were to like get the address and reprint the address isn't the same as how it was. Shouldn't it be the same though, since it is like since it is like this, it's holding the same.
It changed, didn't it?
Yeah. Because you would think that the edges would stay the same since that's just a placeholder or pointer, like kind of, or not.
You would think. By deallocating it, it might be doing something already. It might be something behind the scenes that was something I was about to do. Deleting it might be doing the next, well, fuck, I'll just do the next line. It might be doing something like this. Y equals null pointer. It might be doing that. And when it does, so the null pointer would be at the new address. That it might be doing it behind the scenes.
Gotcha. Okay.
And that is, if it is, it's specific to this IDE. It's not going to work in every program, so don't like. It's not a good idea to assume. So we can say y is null pointer, null pointer, and what happens if we run that after I've said it? Still going to break at the that. Maybe I should just comment it out that line. Oh, it said that null pointer is 0. Interesting. It should be the 0 address. That seems a little suspicious. All right, I'm going to get rid of that line. Let's get rid of both of those lines. So after you delete y, you should set it to, you should do this every time. When you delete a pointer, set it to the null pointer so that you don't make mistakes. It is still usable though. I could say we have x in there. I could say y equals ampersand x, and I could see out y here. Well, int y. And I could put some spaces in, and then dereference it. And so if we had a pointer, it was going to 10. We said delete y, but y was a pointer. And notice I didn't redeclare y. I didn't declare y was a pointer again. I was able to set it to a null pointer. I was able to reassign it to a new address. And when I dereferenced that address, I got the 5 that we have stored in it. So deleting stuff doesn't get rid of the object in memory. It just deallocates the memory, which is good because if it's monsters, you want all that memory to get freed up. Okay. And this happened, making this integer, or the integer pointer right here. This occurred at runtime. So whereas the integer up top, the x, was at compile time, the new integer here, oh, maybe I should put this below it. This occurred at runtime. So employers might have you do, employers almost always tell you to put your compile time variables up here. Invariably tell you to put your compile time variables at the top. When they tell you to do, because every company has their own like preference. Where the employer tells you to put these, changes. A lot of them are just like, as it comes up, that's where you put it in the code. You don't need to have pointers declared at the beginning. This isn't the only type of thing that takes up memory. So we could have, I could have an integer array. And I'll just set them real quick. Again, this is at compile time. So maybe I should move this up top, but I'm not going to for lecture purposes. If I want to do it at runtime, this is how you do it at runtime. It's a pointer, and we'll call it array or ARR. And we're still using the new int. And where we use parentheses up here, we're going to use brackets here. Oh, I don't want a 15 one. There we go. So array 1 equals 7. Array 2 equals 8. Array 3 equals 9. And array 4 equals 10. I guess I could put these each on their own line, but you don't need to. It does make it easier to read, though. So what we did there, let me free up those boxes on my picture. So the first one we did, the A5, it said, all right, let's go to the first spot in memory that has a gap that's 5 wide, and that's going to be A. It's going to point to the first one. And that said 1, 2, 3, 4, 5. And then we made a pointer for an array. So ARR might be stored in here. And it doesn't necessarily have to go like this memory could be occupied and be available later. It just points to another area and gives us our 6, 7, 8, 9, 10 somewhere else. And that one's at runtime, but we have an address stored there. When we want to address deleting an array, this is the command for deleting an array. We do delete, empty brackets right there. That will delete the contents of the array. Array is still a pointer, though. ARR is still an integer pointer. So I'm going to set it to the null pointer. In fact, if I had this delete y up above, let me move this delete y up above. I could have alternatively, instead of making a new array, I could have just said y equals new int 5. And then y would be, then I'd have to do y0 and so on and so forth. Because I already had a pointer, and I already had an integer pointer. Y and ARR are taking up the same amount of memory. They're the same thing. They're an address to an integer. So they're the same thing, even though I used them differently. They're the same thing. I can reassign them at any time. That's kind of a neat thing with pointers. That way you don't need to like have a whole shitload of them. When you do delete array, back to this thing, this deallocates the memory for everything in the array. Still a pointer though. ARR is still a pointer. Okay. And just like Y, I could have reassigned ARR also to X or whatever we got going on. Any questions on that stuff?
So then by putting ARR equal um to that last line right there, then if we ran it and outputted ARR, it'd be 5, right?
If we dereferenced it when we output it. Let me fill this out a little bit better. ARR dereferenced is what the fuck?
That's the address of, no? Operator? You need the pointer?
Yeah, that's tripping. What's going on? Let's try that again. Yeah, there we go. Good question, Veronica. All right, let's go take a look at some other stuff. I'll upload those lecture notes and the announcements. Let's see if we look at the class. You can't see all the assignments for chapter 3 yet because only the first couple things are showing. We're going to do the lessons on linked lists on Friday. But let's take a look at this stuff in dynamic memory here. So I'm going to run this code. I got this code listed somewhere. Okay. So we got this code here. Let's just run it, see what happens. It's 2x plus 3 and y equals 0x plus 0. We'll enter m and a b. I can't tell if it's integers or doubles. I'll stick with, yeah, we'll find out. Let's just make it a double and see what happens. Oh, I don't like it when code does this. Okay, let's say we got 3 lines. Let's go, oh, so it was doubles. Let's go negative 1.2, 3, 3.4, 10, negative 1, negative 1. Nope, negative 2. That also doesn't look good. Plus a negative looks kind of crappy. So it looks like this is just doing a bunch of shit with lines. Let's take a look. They've got a class declared as line. The private variables are m and b. They are both doubles. This looks like it's doing the slope-intercept form of a line. They have a constructor here. We've got our default constructor. That's why we have the 0, 0. I'm guessing that shows up somewhere down below. We've got programs to set slope, which is m, set and get y-intercept, which is b. We have a print line here, and check this out. We have something called the destructor. That is the tilde key. And on PC, it's located above tab. I actually have to do shift that key when I want to type it. So we'll look at what destructors do in a little bit. Notice just like the constructor is named after the class, the constructor is named after the class, so is the destructor. The destructor is also named after the class. let's come down and look at our code. This is saying that we would just put this in line.h as a header file. We had it separated. So part 1, we've got 2 lines being created. We've got line F being created, and it's initialized to 2, 3. That's where we got the 2x plus 3. And G is created, and it's constructed with 0, 0. So it gives me 0, 0. Interesting that it doesn't print out the decimals. Because the decimal 0, it's doing the rounding on its own. That's interesting. Then we've got a print line function, and that's clearly writing out the code like this. Oop. And that's all that's going on there. And then we get to part 2. Then they've declared M and B. We've got a line pointer being created to something called line pointer. They ask the user for M and B. I'm not a big fan of doing this. I prefer prompting for M separately, then B separately, or being a little more specific and saying, put a space between them. With M first. Maybe I'll just do it like that. Or enter M, then B. That way we can tell what the order is. Then it's got the CN, and the first thing it goes to the M, the second one goes to the B. Space and the return key both separate these up. Space does it every time. It's like this makes this line less code here, but it's less user friendly. Once you have M and B, it just makes a new line right there. Line pointer has already been declared. So the variable that the pointer is here, it had nothing assigned to it yet. It was completely unassigned. Then later on, we assigned a line to it, so it points somewhere else in memory. Then we printed out the line. And let's just do it 7 and 2. And notice that there's 2 line printouts going on. There are 2 ways to print our line. When you're using a pointer, pointers automatically lead to this arrow choice. And then, or we could dereference the pointer and then use the dot thing, kind of like it's a function. So like G up here, let's come up here and look at it. The class line has a set slope and a set y-intercept. G didn't have anything there. So I could come along and say G dot set slope and change it. And I got to use a pointer to do it, or I got to use that dot to do it. G dot set y -10. I have to use this dot operator to do it. When we're using pointers, we can use the pointer operator. Visual Studios, if I try to do dot, it's dereferencing it. Look at this. In print line, if I go to print line, it switched the dot to the arrow. Did you guys see that? You start with line PTR. If you do the dot like it's a function, or we're doing something like using a regular class, if I do dot and do print line, it turns it into the arrow. Visual Studios does this. Visual Studios will switch the dot operator to the arrow operator. Not every program will, so you should probably try to get in the habit of using arrows for pointers. I think it's an intuitive thing to remember when we point at something. We've done it every single time. We make a pointer and we're making an arrow when we say it. Every time I've drawn it, I've had an arrow. So like it's kind of easy to remember that's how it's working. So that's going to call the line 3 times. I don't need all that. Let's comment those out. Then, okay, it gets to the end. It says, all right, delete line pointer. We don't need it anymore. And it sets line pointer to null. Interesting. Is that a shortcut for null PTR? Might be. Looks like it is. Looks like null is, you'd also do this. And I will cap that or comment that bit out. Does the same thing. Part 3, it does the array. It asks us how many we want to do. We take in the argument. Notice one thing about this. First off, it is user-defined array size, and we didn't have to do it ahead of time. And it doesn't say constant and nope. When we get dynamic, or when we dynamically allocate the memory, like we do here, we don't need to declare it ahead of time. So when I say dynamic allocation of memory, it means allocating it at runtime. Not when it compiles. Then we've got a loop setting us, taking in M and B, setting the slope, setting the y-intercept, and it goes through, and then when it gets down to it again, it goes through them one at a time, treating it like a pointer, or not a pointer, treating it as an array, because we've set it up as an array. Print, print, print. Again, at the end, they delete the line array. What's going on here? I don't even remember seeing that on there. So what is that doing in the code? 1, 1, 2. That must be the -1, 8. The integer to the line 91 must be this bit right here. It's telling us it's telling us line array was just a pointer. What is the address as an integer for that pointer? Come down and it looks like their stuff is pretty standard here. So destructor. Let's give some more information on the destructors. Just like when we create a new object in main, we get a free constructor call. Like we did G earlier up above. We said line G. It gave us a free constructor call as part of it. I didn't have to say every other thing that's a method in line. I would have had to do G dot so and so, G dot set slope, stuff like that. I didn't have to do G dot constructor or G dot line. It would have been. I didn't have to do that. It's a free call. Destructor gets a free call as well. When we type delete. Okay, usually This is often used for just couts, but there are cases where we'll do more with it, as we'll show you in a second. Instances where we want more. So I'm going to edit this and just have a cout. Cout. Boom. Deleted. Actually, I'll give it a little bit more. Cout, boom, deleted. Line. Destroying. Since this is part of the class, I can just call this right here. Now let's see what happens when the delete stuff happens. And I'll add in an end line here. Before I do it, let's go and find where the first delete is. Right after the y equals, it's right away. We'll see it right away. Back. There we go. It should have done it. Why didn't it do it? Do I never have an end to this? No, it ends. Why didn't it do it? Oh, there we go. Oh, that's where it was doing it. So we've made the line y equals 2x plus 3. Then boom, deleted, destroying line. So this was up here. And maybe I should have added some space after this. So we made the line here. We assigned M and B. It printed it. Line 48 is this line right here. Line 54, when we did the delete line pointer, before it deleted the line, before it deallocated the memory, the destructor is called. Because if it didn't, if it deallocated the memory before the destructor was called, I would not be able to print y equals 2x plus 3 in the destructor. You guys see that? So this calls the destructor for free, which runs before deallocating memory. Let's do that again. Five and 1. I've got destroying line y equals 5x plus 1. There's no way it could have done that if it did the cout afterwards. So that's something pretty handy to know about the destructors. Okay. We can use them to tell us when something's deleted. We can make a cout for it in the destructor. It just basically gives you a workspace to tell people or tell the user when something's going away. It's also a workspace for when we're going to have stuff where we actually have pointers made at runtime inside of these classes. when we start doing linked lists, we're going to have something called a node pointer, and we're going to do a new node right inside this bad boy as a constructor. So anytime we make a new something as part of the class thing in a constructor, we're going to have to do in the destructor as well. Do I have the other program here? That's not the one I wanted. Okay, let's take a look at this one real quick. We'll call it CSCI 2, lecture day 6, C, Destructors. The hell? The hell happened to my program? What do I need to view? View Solution Explorer. There we go. Rude. All right, let's take a look at what's going on here. CSCI 2, lecture day 6. So we've got this class student. We've got first name, last name being stored, and integer being stored. We have two constructors made. One is the default where there's just blank in it. One where we can set the information that we want in it. We've got a print student command. And we've got the destructor. Then we have an instructor class. And the instructor class, oh God, instructor sounds like destructor and constructor. Oh, there's a way to search everything and change every instance of a word in this that's really easy, and I don't remember what it is. I want to find instructor and replace with professor. That's a blind bullshit. It's everywhere. There we go. All right, rewrote the code. Professor, not instructor. Okay, so we got professor. Professor gets to have first name, last name, an ID, and they get to have a student assistant. I know I made this. Oh, I did. I changed the code in the over there. Okay. And so we've got some public methods that go with it, kind of like the other one. We've got our default constructor. We've got our constructor where we enter everything in. We've got a print, and we've got the professor destructor. When we say composition, this means one class is being used inside another class. Composition of classes. Kind of like function composition in math. One class used inside another. It's not inherited. I'm just straight out, flat out using it. And we're going to make it a pointer. And so let's just run it and see what it says. Not a lot here, is there? That was a short main. Professor David Jones, look at these filthy motherfuckers. I gave myself the ID 007, and this son's a bitch just made it 7. How fucking rude. How rude is that? That is so rude. I didn't put you in there, Juan, because I was kind of curious who knows who Inigo Montoya is. Anyone here know who Inigo Montoya is? My name is Inigo Montoya. You killed my father. Prepare to die. So I've got a professor pointer making a new Mr. Jones or Mr. Jones, and Mr. Jones is storing the address of a new professor, which happens to be the professor is an object. It's David Jones. It's storing my first name, my last name, my ID, which it cheated me on, and then it's storing my student assistant. And then it has delete Mr. Jones. What's going on there? Does it say anything? Yes, end of program tasks. Professor Destructor called. Deallocating memory for assistant. Student Destructor called. Professor deallocation complete. Let's go. This all had to have happened. Can we see that the main ended on line 46? None of that shit was in the main, so this is all in the Destructor. Let's go down and look at our Destructor here. Professor Destructor called. We knew that. Deallocating memory. This is where the assistant was deleted. Since it was created in the constructor up here, where is it? We passed in a new student. It was created in the constructor. It's deleted in the destructor. The assistant is set to null pointer, and then we're saying it's complete. So this is a circumstance where the destructor was used for more than couts. It was used to deallocate memory for the assistant. The pointer is still there. The assistant pointer is still there. The pointers don't go away. One handy thing about it, though, is these pointers take up very little room. They are 4 bytes, or basically 1 integer. Comparing that, storing the address, something like that, and then being able to do stuff at memory at runtime, using 4 extra bytes out of something where we have megabytes, millions of bytes, gigabytes, billions of bytes. Gigabyte is billions of bytes. 4 bytes ain't shit. Any questions?
So just to clarify with the professor destructor, we don't need we don't need like a student or an assistant destructor because we're not outing anything. We can just delete it and then set it to null pointer.
Right. The student actually, I mean, we could put something in the student. Where's the student destructor? Oh. Student destructor called. Where did that happen? Right there. So say your question again.
Sorry, I think I just clarified for myself right as you saw it. So when we delete the professor, we're calling the professor destructor. And then in the professor destructor, we then delete the student.
We delete the student, which calls
And
the student destructor.
Destructor, and then that's what prints out student destructor called.
Yeah.
Okay, that makes sense. I was just
So
trying to like fix it in my
right.
mind.
Right. So it's like nested calls right there.
Yeah.
And I never called destructor. Like, oh, this is fun. Let's see this. Where's main? Mr. Jones. What do I have access to? Tilde. Access to student. Oh, I'm fucking it up. Let's try this again. Mr. Jones. I only have access to that one. That's a shame. Do I have a good student? I don't. And it's private, so I can't access it. Ah, that's cleverly made. Well, I can do this. In fact, I'm going to put this up here. I think this might have a problem on the print. Let's find out. Because it should be trying to print the student, and there's not going to be any more student in there. Let's take a look at what happened. So I went through and it made the professor. Then I called the professor destructor, which all it did was come down here. It didn't actually delete professor. It just ran this line of code. When it got to delete assistant, though, it actually went and deleted the student. So then right here is where it finished calling the professor destructor. The professor isn't deleted, so I was able to run print professor right here. And interestingly enough, it did not do my... This is Professor 7. What the... It got to line. I don't know why my first name and last name aren't in there. They should be. They were up here. The 7's still there. Let me comment that line out real quick. Yeah, print my name there with the 7. Why is it when I do this one? You know what? This is probably not the best code to show you on. Let me come over here to the other one we had. We have the line destructor call here. And I put the boom stuff in there. So we have F and G here. Notice F and G, they are, well, I mean, we did the C out for F and G. I can do G dot line destructor. And it's just running the text for that line. G was not destroyed. This is what I was trying to show here. Let me do that again. Let me call this before that. Let's do that. I'm going to call the G, the line destructor for G. Then I'm going to print G. And if it worked, I would not be able to print G afterwards. So G's printed here. That's that second G dot print line. It wouldn't be able to work if G was destroyed or destructed, deallocated. G was never a new line. The point was you can make destructor calls and it will only do what's called in the destructor. Like it print this information, but it didn't actually do anything to G. On the teacher one, it did, because the teacher one actually deletes the student which deallocates the memory for the student, which fucks up the code here when I try to print because the student's in the print. Like it doesn't say Professor David Jones here. That I don't know why it's doing. My name should have still been there. Because, oh, is something else happening between then? No, it's just going straight to print professor. Print professor is right here. It should have printed my first name. I don't know why it got rid of me. This is the line that caused the problem. If I see that or comment that line out, then my destructor up here, my destructor call, doesn't do anything. It was able to keep running everything because this line call didn't do anything other than delete the student. I don't like that line. Let's get rid of it. Undo, undo. And come over here and just delete it. That's kind of all I had to really say about the delete and the destructors. You guys have any questions?
I think I understand like conceptually like what it does, but I'm not really understanding like when we would use this, if that makes sense.
Use what?
Use like the destructors type thing. Because I get like
You won't do what I just did, where I was doing the tilde, typing the tilde myself. You wouldn't do it. It happens automatically when you do deletes. Destructor is called automatically here. If you don't have any comment put in that destructor section, it still does the destructor section, but there's nothing to see.
Mhm.
So like if I like completely comment out this section,
It would still call it, but we wouldn't see anything.
it's still calling it, but there's no evidence on screen. Exactly.
Okay.
But if you need to know when something's going away, or more importantly, you may never do see outs. You may not want to show that. You may not want to show that, and you may not want to show that. But the assistant we made in the student program, we had a pointer here, and the act of calling the constructor made the new student as part of the constructor. There is no way to deallocate that memory without deleting the student. And that we don't have any other way to get to that thing.
We don't have any other way to delete the student without calling the professor destructor.
Right, because notice we don't have a get student anywhere.
Mhm.
We have no way to access that student information.
Without
It's taking up memory, and the only way to get to that, this is actually a good thing to show in a picture. So we got our professor memory over here. This is professor memory over here. And student memory is right here. And when we did the Mr. Jones thing, Mr. Jones pointed to here, professor pointed to here. Well, this is the only pointer we got to student. So, like, if this code wasn't super short, like if we deleted Mr. Jones and the program was over, when the program's over, the memory's deallocated anyways. But if this was like something that was going to be a really, really long program, and the professor's out of the picture in the beginning, like a character in a book that dies right away, we don't want memory being held up for it So we would want to delete the professor. So the professor is no longer in the story. But unless the professor destroys the student, unless the professor does this to the student, there's no way to delete the student until the program ends, which could be the entire rest of the book. Like, let's say it's a 400-page book or 400 line program, and the professor's gone within 10 lines, and the rest of it, it's a game that you're running for hours. That memory is allocated the whole time unless professor deletes it, because professor's the only one with that pointer. So when we delete the professor, we delete the student. Does that kind of make sense?
Yeah, that visual actually helped a lot. That makes a lot of
I thought it did too. I'm glad I thought to do it.
sense. That helped a lot.
Because you can see the arrow, there's no other handle on the arrow. I'm glad you like that, because what we're doing next with the linked list is very visual thing. We got a lot of arrows, and tracking what we do with the arrows and as we're doing it is gonna like doing it visually makes it a lot easier to figure out how to do the code. And you'll see on Friday. That's for another day. Linked list is gonna take a while, and I'd rather have that for the main class. Anyone else have any questions? Kenny? Oh, it's only you and Veronica and Kenny today. Juan's here, but Juan's just supervising, right, Juan?
Yes, sir. Still here.
You guys not know who Inigo Montoya is?
No, I've never heard of him.
It's on Princess Bride.
I don't think I've seen that.
Oh, you've never seen Princess? Oh my God! Princess Bride is fucking fantastic. It's an old movie.
I've heard of like the Princess Diaries. I don't think I've heard of Princess Bride. No.
My name is Inigo Montoya. You killed my father. Prepare to die. Maybe if you see a picture of it. Now I'm loving that. Like, let's go to YouTube. Do I have? Let's do optimize for. There we go. Optimize for video. Inigo Montoya.
Okay, that looks
On September 29th,
Right.
only one movie event
The Paw Patrol.
has meteor showers,
Ow!
epic powers, dogs who rock, and cats who talk.
I have so much to say. Give me that.
Paw Patrol, rated PG, September 29th.
Good heavens. Are you still trying to win?
Can you guys hear it?
You've got an overdeveloped sense of
Yeah, it
vengeance.
sounds pretty good.
It's going to get you into trouble someday.
My name is Inigo Montoya. You killed my father. Prepare to die.
Can't even stand.
Hello. My name is Inigo Montoya. You killed my father. Prepare to die. Hello! My name is Inigo Montoya. You killed my father. Prepare to die. Stop saying that! Oh. Hello! My name is Inigo Montoya. You killed my father. Prepare to die! No! Offer me money. Yes. Power to promise me that. All that I have and more. Please. Offer me everything I ask for. Anything you want. I want my father back, you son.
So this guy this is the end, near the end of the movie. He's not even the main character. The whole movie, he's looking for this guy that killed his dad, and he doesn't know who he looks like. And he has a clue. If you haven't seen the movie, I'm not gonna like. I already gave enough away that they're trying to kill this guy, but he has a clue as to who the murderer is, and eventually he finds out the clue gives away that guy. But he has been giving this speech the whole movie to the other characters about what he's gonna tell that guy when he finds the guy that killed his dad. Princess Bride is worth watching. Veronica, ask your mom if your mom thinks you should watch Princess Bride. Hi, Mom.
She seemed kind of ashamed that I didn't recognize it.
That's the right response, Mom. Good job, Mom. I approve. It's a little embarrassing. It means you haven't been doing your job as a mother. You're supposed to like inbred this kind of shit in her.
I know.
Teach you that stuff. All right. That's all I got for you guys. I will see you guys on Friday. Watch Princess Bride if you haven't seen it.
Will do. Good night.
Night.
Good night.